strict note is that the real world is not commutative. I repeat, strict note. Nature is naturally not commutative. Why should we say that? You cannot do the dinner at the morning. You cannot do the breakfast after dinner. Everything has the order. You don't wear your underwear after wearing the full dress. You follow the orders. Nature is naturally non-commutative. 3 into 6 is not equal to 6 into 3. I repeat, 3 into 6 is not equal to 6 into 3. If you try to follow the commutative rules in statistics, then that statistics is not going to tell you the real story. The internal principles of the nature is always non-commutative. As per Sanjoy Nath'S Geometrifying Trigonometry rules, plus, minus, into, divide, everything, every operators are non-commutative. So 1 plus cos x plus sin x is not going to tell you the same story as cos x plus sin x plus 1. So when dividing these two, we get a numerical value 1, and that is the starting point of wrong statistics. And that statistics you use in market analysis, and so you cannot predict the market properly. Have you ever seen that the statistics is going to give you the real figures or real understanding about the market? No. And the statistics is standing on the simplification of the numerical calculations, and numerical calculations are just the simple thing for child game. In reality, every real number is depicting 16 different possible triangles, and these triangles have the edges, 3 edges, and each of these edges have the different meaning, and these edges set the trend lines for the share market. Here, as per Sanjoy Nath'S Geometrifying Trigonometry rules, Caliperness as the intrinsic energy of the market, which follows the least energy principle, and which is naturally natural phenomenon. The least energy principle is followed everywhere in nature. Even you look at the Newton's laws of motion, even you look at the laws of friction, even you see the laws of gravity, you see the Planck's law, if you see the Einstein equal to mc square, even you see the Lenz's law, even you see the rules of the physics, biology, then why not in economics? Everywhere, if the thing is naturally natural, then first principle is that numbers don't show the reality. The reality is geometric in nature, and numbers are the rough calculations which are simplified version of reality, and simplified versions don't go deep inside the reality. That cannot tell you the real story. First thing first, think everything as a non-commutative, think everything as ordered. If you know the real right order, then you can predict things. If you don't follow the order, and if you think that haphazard way of writing can give you the good results, then you are doing the big mistake. That means you are trying to do PhD first, then you will go to school, then you will learn ABCD, and then you will complete your 10th board. Then after doing that, you will try to live happily, and it is a chaos, it is not the order. And if you try to do these kind of things, then nature is against you. Caliperness is the measure of straightening the polygons, and the trend lines are polygons, and falling market releases energy following the least work principles. Note, the if it releases energy, then also it follow the least work principle. Raising market gains energy following the least work principles. It will never follow the highest work principle or any kind of things in between. Least work principle is naturally natural. Now, how to calculate the least work is the challenge. To answer this question, first of all, we will try to explain the concepts from the moving average point of view. Types of moving average. The simple moving average, the average of of a set of prices over a specified number of periods. Say n number of periods are there, and n number of periods are going to give you n number of trend lines. These are the trend line like this. These are the caliper edges, and these are the fulcrum points at the junction points where the trend lines are changing its gradient. And the formula of simple moving average is just take the numerical summation of the prices and divide it with the total number of prices there. And that is a wrong concept, and we should not think the things so simplifically. Simplifical ratio of numbers is not going to give us the real pictures of the whole process. In the engineering geometry also, we try to understand things as the straightening of the line segments such that we can model it as the beams, columns, etc., and we can process the whole systems sequentially. And in computer science also, we handle with the stacks, that is the last in first out. The last one is handled first, then the next one, then the next one. In this way we handle the things, and we have seen that the experts talk in the stack exchange. We have seen that people say that there is a stack overflow. That means when we are pushing things one after another, one after another, the last thing comes up, and when it cannot get stored, then it is a stack overflow. So for any kind of analysis, the current time is the top of the stack, and the bottommost thing is the start of the period from where the stacking started. The trend lines are the stacks, and stacks of what? Stacks of work done. These are the stacks of work done. Now, just taking the ratio of a pure number divided by a number is not going to tell you the real internal energy inside the market system, because the market is a multi-body system where every of the bodies, every of the objects are attracting, repelling, or doing some internal works. The whole story, whatever is happening inside, looks like chaos and looks like entropy. And we try to measure the temperature of the market, we try to measure the heat inside the market, we try to measure the thermodynamics of the market, and we try to make our life easy mathematically, but using the wrong mathematics. The right mathematics is to think everything geometrically, where you have to follow the sequence. You cannot follow the Euclidean geometry with a non-sequential way. Suppose if you want to find the point of intersection of any two lines, first you have to draw two lines. Otherwise, the point is invalid to find the intersection. Intersection is the common point of two lines. First you have to have two lines. Until you have two lines, then you cannot think about the point which is common in these two lines. You have to follow the sequence. Now comes the exponential moving average. Here it is a simple talk that gives the more weight to the recent prices. What does that mean? Giving more weight to the recent prices? It is actually the sequential straightening process where the last in first out, that is the last trend line, is to straighten first, and you have to hold the start trend line as your reference. As we were saying that 1 plus cos x plus sin x is not same as cos x plus sin x plus 1, because when we are writing 1 plus cos x plus sin x, then we are holding 1 as the starting period trend line and rotate the last term such that it can align with the second last term, and in that way we sequentially straighten the polygons, and the trend lines are the polygons. In the exponential moving average systems, we see there is a recursiveness, that is, the previous moving average is the controller of the current moving average. So the last trend line that we can see is controlled by the previous trend line, and that previous trend line is controlled by the previous to previous trend line, and in this way the whole exponential moving average works. But it is not working because you have assumed that the things are commutative. No, nothing is commutative in this world. Nature is naturally non-commutative. Now, coming back to the Caliperness of Sanjoy Nath'S geometrifying trigonometry. Here we have broken the whole period from the start of analysis period to the end of the analysis period. And before coming to this straightening, because in the next part of this training video we have shown the straightening process for the simplest cases, you can move forward and can see that. Here, first of all, we have to talk about the benefits of the moving average that you can see here. That is the trend identification. It's a rough calculation, helps in identifying the direction of the trends upward, downward, sidewards, and that is taken as a commutative algebra, where 3 into 6 equal to 6 into 3 is considered. A rising moving average indicates the upward trend, while the falling moving average indicates a downward trend. Okay, any child can understand that, but what is the internal energy? What is the work done while moving downward or while moving upward? Some work done is done inside the market, na? How to measure that? Now, support and resistance level. Moving average can act as a dynamic support as the resistance levels. Prices often tend to bounce off these levels. No, these are just the overview of the iceberg. These are just showing the tip of the iceberg, but the reality is hidden inside the ocean. Please try to understand. These signal generations is not going to give you the understanding. You have defined several terms just on the superficial views, and these numbers are just going to give you the superficial views. These are not going to tell you the real story, what's happening inside the market, and it's looking as if we are just trying to play the number game without understanding the internal working principles. Now, moving average cannot give us the reality. There are several kind of guessworks that we do with the property of numbers. Then stop playing with the share market. Go to the number theory and try to play game with the number theory. If you want to work with the moving average kind of statistics, then forget share market and go to somewhere where numerical games are done. Follow some jigsaw puzzles, do something like that. You should not come to this heavy game. Okay, the heavy game starts here, where the rotational energy of the trend lines. Every trend lines are like the rods. Like these are the rods and these are the trend lines, and these trend lines rotate one at a time. These rods rotate one at a time and sequentially. Last is rotated first and first is never rotated, and in this way the rods are rotating. Now, rotational energy. Rotational energy or the angular kinetic energy is the kinetic energy due to the rotation of an object and is a part of the total kinetic energy, and where there is a thing called moment of inertia. Now, the rod has a moment of inertia. The trend lines are like rods, and that has a moment of inertia, and when it is rotated, it does some work. Now the last rod is rotated, which does some work, and then the second last rod is rotated, and that also does some work, and in that way the total work is calculated, the last rod is rotated, and to calibrate itself with the previous one, then the whole sum is rotated, the whole rod is merged together, and that rotated, and that is rotated, it is also doing some work, and in that way the total work is calculated. But share market is not rod, share market is a whole polygon, because under this rod, under this tip of the iceberg, the whole involvement of several players are there. So this total involvement is the area under this rod, which is a polygon, which is rotated to calibrate itself with the previous trend condition, and then the bunch of line segments is generated, which is the next target level of calibration. So after this first level of calibration is done, then only the second level of calibration is possible. So the last trend line, that is the current position, is rotated first, and with that the whole energy of the current time period is aligning itself with the previous conditions of the situation where it was, and to do that, the whole current energy is calibrated with the previous energy level, and that previous energy level was also had to calibrate with the previous to previous energy level. And to do that, we need to calibrate, that is straightening, that is the calipering, the straightening effort of this whole thing with the previous to previous situation. And after this whole bunch of line segments are arranged, then the previous to previous to previous is aligned, and in that way the total energy is calculated, and this way we get the real real work necessary to do it. Now we could do it anti-clockwise, we could do it clockwise, and ultimately in this way we reach to the straightened first point, and that is the total energy consumed to achieve this trend line. So this whole trend line is actually a proportionate distribution of the scenarios, such that the total market energy is aligning with its previous situation, and with this way we can analyze the things in two-sided analysis. Suppose this one is a trend line. First of all, in the same way as we have talked here, first of all we will hold the first point, and in the second case we will hold the last point, last trend. And in this way, when we hold it tightly and we calibrate the whole polygons as I have shown previously here, this consumes some energy. Again the sequential straightening consumes some energy. Again the sequential straightening consumes some energy, and ultimately that is consuming this energy to reach that situation. This is the analysis 1, and we will do the same thing in the reverse way, where we have hold the last trend, and in that way we rotate the first one first, that is the queue like operation, where first in first out, which is not stack, that is the reverse of the stack is the queue, where the first in first out, where the first one is rotated first, then the second one is rotated and aligned with the next one, then the whole bunch is rotated or third and straightened like this, and this calibration is done, then that is rotated about the last line. You can see that these two things are not same objects. these two things are different objects. Are these parallel? Are these mergeable? Not always, not always, dear, because I have taken this example here. I can show it with a simpler case like this, where the things are like this. Say the first one hold is like this, and if we take the last one hold is like this, and then you can see the story is different, where after straightening you see this, then after straightening you can see this, and for this case, the first in first out, you can see that the rotation is happening like this, and there you can find that sequential straightening process is not going to give you the same thing, and a virtual triangle is constructed. This is the division triangle, that is the effort to rotate, effort to do the ratio, and this is the ratio effect. And these kind of statistics are the geometrical statistics. These are not the numerical statistics. Numerical statistics cannot tell you the real story, and that will always confuse you, and you cannot predict the market. To predict the market, you have to use the work done calculation for the polygon's rotation. To calculate the polygon's total moment of inertia, the formula are there, and the work done is the moment of inertia into the angle of rotation. Now the angle of rotation is the uh, deciding factor, that is the tactic uh, energy. The whole market has a tactic energy itself, and that is which direction to rotate, anti-clock or clock, which way to proportionate the distribution of these polygons. These are all the intrinsic factors hidden inside the market, and to expose those factors we have to do the geometric statistics. We should not follow the commutative numerical statistics. Commutative numerical statistics will always confuse you, and the things will look like chaotic. The least work principle is everywhere. The least work principle, also known as the principle of minimum potential energy, is a fundamental concept in physics and engineering, particularly in the study of the structural mechanics and elasticity. This principle states that a system in the equilibrium will adopt a configuration that minimizes its potential energy. This is the catch point. The market trend is itself a potential energy holder, like the kind of trend that you are seeing here, which is a potential energy holder, and the whole market has interests there. The interest means the people's interest, the investors' interest, the buyer's interest, the seller's interest. Everyone's interest determines the interest rate. So the predicativity analysis, you have to know the term predicativity. That is, predicativity is an important concept to understand the ontological basis. That is the ontological basis for the understanding of reality. That is the ontological basis for understanding the reality. That means when human being started talking, then the words came to their mouth. Word 1 came first. Suppose that was the food. Then that word generated some concept, and obviously some concept came first. Some concept came first. Some understanding or some concept came first. Then on the basis of that concept, the word 1 came first, and due to that word 1, some secondary concept generated. Due to that word, some secondary concept generated. On the basis of word 1, and due to this word 1 and the secondary concept, some word came, that is word 2. that is some term 2 came. On the basis of these two things, some other concept came up, that is some tertiary concept came up, that is some tertiary concept came up, and due to that tertiary concept some word 3 came up. In this way we are standing in the world where we have n number of words. In this way we have the n number of words. Word n came last, the word 3 came third, the word 2 came second, obviously. So do you think if the concept of time, some concept of time came first, then some concept of time came first, so until the word time came, word time came, on this basis the concept of future came, on this basis the word future came, on this basis the word called future came, and on the basis of the time and future then another concept came, that is future need. Concept of future need came, and future need needed some other word, that is guaranteed future need. Word guaranteed future need. Then on this basis the interest is the concept came, the concept of interest came, concept of interest came, and until this concept of interest comes we cannot think that the word interest can come. So the word interest came on the basis of time as a function of this concept of time, concept of need, concept of future, concept of guarantee. Until these concepts come, you cannot think that the word interest will come to the world. So obviously this stacking upward is the predicativity analysis. This is the predicativity analysis, and here is the concept of predicativity. Predicativity. Don't confuse with predictive need. Don't confuse the predicativity analysis with the predictive analysis. Don't confuse that predicativity is like predictivity. Don't confuse that predicativity analysis like predictive analysis. So, Caliperness is like predicativity concept. Caliperness, Caliperness, in Sanjoy Nath'S Geometrifying Trigonometry, is the sequential straightening of polygons or polylines or trend lines, that is such that least energy principle is applicable on the market trends. That means you cannot do the market trends analysis with the internal structures of the market, internal behaviors of the least energy principles, least work principles happening inside the market. You cannot do the analysis until you know the predicativity conditions that's happening on the market. And predicativity is the first concept first, second concept second, third concept third. In that way, it follows the recursiveness, and the last concept stands on the last to last concept, and in that way sequentially the last one in the stack is dependent on the previous one. So the order of the sequence objects is important. You cannot do just direct average as the numerical values. I repeat, 3 into 6 is not equal to 6 into 3 in reality. So the least work principle had the catch point which says that a system in equilibrium will adopt a configuration that minimizes its potential energy. In the context of rotating a polygon about the point in the 2D space, applying the least work principle involves determining the configuration or the path that requires the minimum amount of work to achieve the rotation. In the market trend lines, we can see that the market trend lines are just the top of the icebergs, and which are like the top rods of the whole polygons, and the whole polygon stores the total energy of the market. And when the last stage of the energy is rotated to align itself with the previous one, then it consumes some energy, and that energy is necessary to calculate sequentially. You cannot define the term interest until the concept of the time is in the mind of people. You if Suppose if the world destroys tomorrow, if there is no time for anyone, then who will borrow money? Then who will invest? No one will take interest, because the interest stands on the concept of time. If the concept of time is vanished, then the concept of interest will also vanish, because people define future in terms of the concept of time, and until the concept of time is there, the concept of future vanish. If the concept of future vanish, then the concept of interest rate is also going to vanish. The concept of banking is also going to vanish. The concept of market is also going to vanish. So the time is the most fundamental object on which the other concepts are standing. Similarly, the potential energy, that is the potential to fall or potential to rise, these are the energy dependent things, and the energy dependent analysis are always sequential. Those are never done in a number like game. So using the number like game with the statistics is not going to give you the real picture. In the statistical mechanics also, we use the term ensemble. What is this ensemble? Ensemble means multiple type of things having same numerical value but different geometric internal configuration, and all of these are having equal chance. When many of the things, so thing 1, thing 2, thing 3, all of these are depicting the same numerical value, but can have the possibility to appear in different geometric shapes, and the set of all these equally possible geometric objects is called the ensembles. And in statistical mechanics also, we do a rough calculation with the ensembles, and Sanjoy Nath'S geometrifying trigonometry is also claiming the same thing, where multiple bunch of line segments can have the output line segments whose lengths are all same, but the geometry of all these different bunch of line segments are different, and this set of all these bunch of line segments is forming the ensemble of bunch of line segments, that is the ensemble of balls. And with that way we do the geometrically done statistics, where the fundamental rule is everything is non-commutative. Plus is non-commutative, minus is non-commutative, multiplication is non-commutative, division is non-commutative. One more interesting thing is that plus, for every plus operator, the four different possibility opens up. For every minus operator, four different possibility opens up. For every multiplication operator, four different possibilities open up. For every division, four different possibilities open up. So every number can have the 16 different triangle possibilities. And in share market analysis also, you will find that the 16 comes up regularly, and people get confused why so much less probable our calculations are. Our daily use statistics is always giving us a condition where practically 1 by 4 to the power n, which is very common in our statistical world, 1 by 4 to the power n, we don't get the answer why this factor always comes. And even in the power series analysis, even in the infinite series cases, we get pi square by 4 to the power n, and this 1 by 4 to the power n is very common in our statistical calculations. Sanjoy Nath'S geometrifying trigonometry answers that every operator has the four possibility opens up, so 1 by 4 to the power n is quite natural in the non-commutative world, and nature is naturally non-commutative, and always having a four clean four symmetry, that is the four symmetry is always there. Suppose that you can understand very easily if we type capital F here, and if we take the capital F, then if we take the mirror image of this F, say we are taking a figure like this F, like this F, and if we do the mirror symmetry of this, then we will get the image like this, and that is a different image than F. Now if we rotate this F 180 degree, we want to copy this and we want to rotate this 180 degree, then we get another symmetry, and this symmetry is like this. And if we rotate this 180 degree, then we will get another symmetry, which symmetry is like this. And now the question comes is, all these four symmetries are unique, and you cannot achieve any of the other two by simple rotations. If you try to rotate this, and if you want to get the other object, then you can get one object at a time. Suppose if you rotate it 180 degree, then this one will look similar as this one. If you rotate this 180 degree, if you rotate this one 180 degree, then you will get the overlapping image like other one. But until you do the mirror image, you cannot achieve every kind of thing as the four kind of symmetries. So 180 degree rotation is also important, and mirror image is also important. Two symmetries are mirror symmetries, and two symmetries are 180 degree symmetries. You cannot achieve these with the rotation effect. Suppose if you want to rotate this one, and if you want to achieve this second one, you cannot achieve that. You have to do the mirroring to get the second one. And if you want to achieve the other two with the mirroring, you cannot get that, because mirroring will give you two symmetries and rotating will give you two other symmetries. So ultimately four symmetries are there, and every number has four different possible trigonometry ratios, and every trigonometry ratios has a four symmetry. So ultimately the 16 numbers of possibility opens up for every number. So if you try to do the simple additions in the orderless way, like the commutatively, then that statistics is not going to give us the predictive power on the market, because the market itself is a non-commutative. And if we try to follow the commutative rules to simplify our analysis, then that is not going to give you the reality. Now here the rotation of the polygons of the points need have the moment of inertia for that polygon, and the distance from the center of gravity to the rotation center is the radius of rotation, and with that the rotation work done is equal to moment of inertia into the angle of rotation. We minimize the angle of rotation through the anti-clock deciding or clockwise deciding. These parts are the part of the caliperness, and we have already discussed that caliperness is the measure of the total effort of straightening the multi-calipers. This effort is the tactic effort. The market has many players, and everyone has the tactic 1, tactic 2, and these tactic efforts are summed together, and the total rotation effort plus the holding effort, that is the first trend polygon is hold tightly, or the last polygon is hold tightly. If the first polygon is hold tightly, then it is a stack like behavior. If the last polygon is last trend line is hold tightly, then it has the queue like behavior. So the market analysis need to get done as a stack like behavior and also like a queue like behavior, and then we have to find the triangle which fits best for the least work principle. And in that way we have shown that four possible kinds of triangle generation, and it stores some area inside it, and that is the measure of ultimate energy stored due to the queue like behavior of trend and due to the stack like behavior of the trend. And the queue like and stack like behaviors gives us the two line segments, and the third line is added as a complementary line, and then we get the energy stored inside the trend analysis, and with that energy minimization we can get the perfection of our analysis. Caliperness is the mathematical object which measures the total effort to straighten a multi-caliper. A caliper objects look like these things, and which has a fulcrum point, which has a left edge, which has a right edge, and the effort to straighten is defined in this way. Caliperness is the total effort of straightening multi-calipers. This effort is a tactic effort plus rotation effort plus holding effort plus sliding effort plus scaling effort plus lifting effort plus effort if any lifting and shifting is necessary, plus breaking of the fulcrum effort. There are multiple types of efforts involved in straightening a multi-caliper. First of all, we have to understand what are the calipers, what are the multi calipers, and suppose this is a caliper object and we have to think it as a multi caliper object, then we have to place this fulcrum point at different positions, and we can get a tree like object, and these tree like objects generate the constructions, and sometimes these tree like objects have a rotated objects also, and these rotated objects involve into the geometry and that forms the triangulations like this. And due to this triangulation, it is a multi-caliper object, and all of these rotated calipers at the fulcrum points are rotated anti-clockwise or clockwise, and then construct the triangulations, and from those triangulation again the new branches come out, and in this way we can get the multi-caliper kind of objects. To make the things simpler, we can talk it like the share market graph, which looks like these kind of things, and where something grows down, come down, again grows, again grows, again grows, come down, again grows, get flattened or steep rise, again flattens, then come down with the different gradients. And people think it as a normal mathematics of graph, but in geometrifying trigonometry it is thought of as a multi-caliper objects, and there is effort to straighten it. Now if it is a multi-caliper object where the fulcrum points are placed at every point of change where the graph changes, then it is a multi-caliper object, and for the multi-caliper object we need to straighten it to get the total effort necessary to get the total journey traveled in this whole process. Suppose whenever a share market comes down or goes up, whatever it is happening, then at every point the market is deciding that there is a movement, and that movement is upside down or downside up, whatever it is. Then if we measure the angle here, if we measure the total deviation occurs, is it happening clockwise or is it happening anti-clockwise, and in this way our programmers need to calculate the total effort such that we can give the instructions to the people that how to think about this kind of polylines, this kind of polygons, and these polygons we have to calculate it as a rotation effort. If the rotation effort is clockwise, then the total degree change is sometimes theta 1, and the opposite side it is 360 minus theta 1. So if this angle of rotation is theta 1, suppose this angle is theta 1, then if it is theta 1, then opposite angle is obviously 360 degree minus theta 1. That is, if this one is theta 1, then we can understand that if we have to rotate along this direction, then we have to travel theta 1 clockwise, otherwise we have to rotate anti-clockwise 360 degree minus theta 1, whichever is the smaller is taken, because the no one in this world wants to do the more effort to get the same result. It is not only that, it is also shortening its size. That means the length of this edge was bigger and this one is smaller, so ultimately it has a shrinking effect, and this shrinking effect is also a effort, which is a scaling effort. Now the total effort needed for this down movement or up movement or whatever the graph is taking its shape, there is a trend movement shapes, and these shape movements are done properly as per the geometric calculations, and these are not to consider as the algorithmic complexity. We should not consider it as the computer science algorithmic complexities. We should think it as the geometric complexities to straightening the whole things sequentially. Now at the start point, where if we consider any kind of algebraic expressions or trigonometry expressions, or if we consider any kind of expression are non-commutative, then it is more syntactically strong, and then the non-commutative objects are more meaning representing things, and ambiguities reduces down. For the cases where the commutative things are allowed, then ambiguity increases. Suppose if we say that any text is written as the this is mm, this is engineering, and if we take it as a commutative, and if we say this is engineering is same as this engineering is, and that is same as is this engineering, then this syntax is non-commutative. That means the order of writing is immaterial. But is it really so? No. In any kind of syntactic system, the order of writing is always very important, because as per the rule of grammar, as per the rule of grammar, the grammar talks about the syntax, and syntax are always non-commutative. Grammar talks about grammar talks about syntax, and syntax are not commutative. So the order of writing the terms is very important. Order of writing terms is important. And if the order of writing these terms are not important, then the LR parsing or RL parsing or any kind of parsing cannot work. Parsing systems work where grammar are properly well defined and well ordered. That means for the grammar there are some noun phrase, there are some verb phrases, there are some noun phrase, and these noun phrases are there with the terminal symbols, and these noun phrases are attached with the verb phrases, and then the syntax is important, because these noun phrases always attach with some verb phrases, and those verb phrases are the actionable objects. These verb phrases connects the noun phrases differently, and then it prepares the meaning, and the parse tree systems can work, and these parse tree systems work only and only when the syntax is well ordered, and well orderliness is very important. And if we consider anything as commutative, that is reducing the power of the languages. Commutative algebraic structures are too much abstract, which hides the concrete actions. So engineering graphic systems or the share market graphic systems always have a ambiguity, because we consider things as commutative, but here in geometrifying trigonometry we will enforce everything as a non-commutative, such that the order becomes very important. Like, suppose if we consider the 1 plus cos x plus sin x, that is different, that is different, it is different meaning from cos x plus sin x plus 1, and it has the different meaning from the sin x plus cos x, sin x plus 1 plus cos x. It has a different meaning from the sin x plus cos x, sin x plus cos x plus 1, and these all have the different meaning. There are three terms, so factorial 3 is equal to 6 types of orientations and 6 types of different meaning are there. We have to know that 1 plus cos x plus sin x, 1 plus cos x plus sin x divided by say sin x plus cos x plus 1, that generates a triangle, that generates a triangle, and this triangle say look like this. And if we take it as the sin x plus cos 1 plus cos x, and that is divided with say this one, then it can give us a different triangle. Obviously it will get related with this, but suppose in that case the triangle is different, and obviously it can mean something different, like this. It can have the different geometry, and so we should consider that both of these are numerically one, but geometrically they are talking about the different kind of syntaxes. I will explain it thoroughly after explaining the Caliperness measures. Now here in engineering, when we are considering this, rotation is an effort and scaling is also an effort. In this way, first thing first, we have to use the hold operator, that if we are writing it as a 1 plus cos x plus sin x, then we are holding the first term, and if we are writing it as a sin x plus cos x plus 1, then we are holding sin x term. I should explain it first here. I think then it will become more interesting to explain this. I will explain this here. Suppose this one is a triangle, and when this one is a triangle, this is say this is the pivot point, this one is the stretch point, this one is the nodal point, this one is hypotenuse, this one is perpendicular, and this one is the base, that we all know. In this way we think about the things. This one is the base. Now if this is the condition, then if this is hypotenuse and this is taken as the L equal to 1, then this one becomes L star cos x, this one becomes L star cos x base, and the seeds angle is x. Here the seeds angle is x, so the perpendicular becomes L star sin x. We got it now. Now if we write it as, suppose if we write it as 1 plus cos x plus sin x, this means L equal to 1, hold this one tightly, this means 1, and hold this tightly, hold this tightly on the space. First term is hold tightly, always we will hold the first term very tightly such that it will not move, because the whole concept is non-commutative, so the order is important. The first term is hold tightly. Now it is saying that cos x plus sin x, that means with the 1, after rotation, after straightening, this cos x will remain attached with 1, so we have to get the effect of rotating this cos x about the pivot such that it will remain attached with the 1. We will have to get this thing rotated in such a way that will remain attached with 1, because the expression is saying 1 plus cos x plus sin x. So 1 and cos x should come together, and then sin x should come after that, which will remain attached with cos x. How can we achieve that? To do that, we have to cut the point at the nodal, otherwise we cannot get this effect. To do this, we have to consider the geometry like this. We will cut at the nodal point, then we will rotate this L sin x about the stretch point, when cos x and sin x will become collinear, and after this collinearity is achieved, then sequentially we will rotate the whole bunch of line segments, like the sin x part and the cos x part, together about the pivot point, such that we can straighten it and we can get the 1 plus cos x plus sin x in an order, and that order is expressed here in this expression 1 plus cos x plus sin x. Similarly, if we try to say that no, we want to write it as the cos x plus sin x plus 1, if we have to write it as a cos x plus sin x plus 1, say if the order is written like this, then obviously we are holding the cos x line segment first, and we will hold the cos x first. So we will do this like this. We will hold the cos x part first, and we will not allow this cos x to move. Now we will see that sin x is attached with cos x, and then 1 is attached with sin x. To achieve that, we have to rotate this 1 about the nodal point, such that the 1 will remain attached with sin x, and to do that we have to cut the pivot point, because the pivot point cutting is necessary, otherwise we cannot rotate the 1 about the nodal point. Here the effort of planning, the tactic effort, is that since the 1 comes last, this comes last, which means we have to rotate it first. The last term is rotated first. The tactic effort is the last term is rotated first, like the stacks, last in first out. In the stack data structures, we see that the last in first out, the last term is rotated first, the second last term is rotated sequentially later, and the first term is never rotated. So we have to cut at such a point where the first term will remain free from rotation. To achieve the first term free from rotation, we have to know either pivot point or stretch point are attached to cos x. Nodal point is never attached to cos x, so we have to cut either at the pivot point or at the stretch point. When we will cut the pivot point, and when we are holding the cos x tightly, then only the line segment 1 is allowed to rotate about the nodal point. So the grammar works in a active construction language. Now this active construction language has the Caliperness point coming in. Now sequential rotation has a tactic model. Here cos x is held tightly, so we have to cut the pivot point and then rotating about the nodal point, such that the 1 is attached with the sin x, and 1 becomes collinear with sin x. So the last two terms, the 1 and sin x, becomes collinear, and after this collinearity is achieved, now we are allowed to rotate the whole thing of sin x plus 1 about the stretch point to make the straightening occur. And when L cos x, that is held tight because it is the first term, and in this way the straightening is happening. And here we have seen that 1 plus cos x has a different geometry, cos x plus sin x plus 1 has a different geometry, 1 plus cos x plus sin x has a different line segment, and the cos x plus sin x plus 1 has a different line segment. Now when we form the triangulation, we can think it like this, where the common point is placed like this and a new triangle is formed, which is due to the division of this cos x plus sin x plus 1 and 1 plus cos x plus sin x. This division is creating a third triangle, and to generate this we have done some effort. This kind of effort is the geometric effort, but that is not the Caliperness effort. Caliperness effort is only up to the straightening part. This is the geometrifying trigonometry triangulation effort, triangle generation effort that occurs during the division. And the ratio effort, we can consider it as a ratio effort, and ratio effort is defined, the ratio effort is different from the Caliperness effort. I think you got it, that the ratio effort means where some bunch of line segment is on the numerator and some other bunch of line segment is numerator is a bunch of line segments, denominator is another bunch of line segments, denominator is another bunch of line segments, and the division is done, and that division is the effort used to generate the ratio. This total effort has something to say here. It says that numerator is found with a output line segment which has a particular length, and that length is a number. The denominator is also depicting some output line segment, that is also output line segment which has a particular length and that has a number. These numbers divide to give us the numerical ratio, but ultimately the numerator is a bunch of line segment which can look like this, and which has different other triangulation properties also, like this kind of triangulations are commonly visible. And suppose the numerator bunch of line segment is like this, and the denominator bunch of line segment is also a bunch of line segment, that is a ball subject, and ball subjects are the superclass which has the subclasses, like line segments are also the bunch of line segments, the point is also a null bunch of line segment, locked sets are also bunch of line segments, GT simplexes are also a bunch of line segments. This is a GT simplex kind of object where the pure multiplications are there and plus minus are not involved. These are the GT simplex objects. And suppose the denominator is also a bunch of line segment which has the different geometry, say altogether it has a different geometry, but it has also output line segment, and the output line segments interact, and the initial line segments are also there, that there is a separate training videos for that. And when these bunch of line segments are interacting due to the division, the output line segments both have the output line segment. Suppose this one has the output line segment, this one also has the output line segment. Suppose this one has the output line segment, this one and this one has output line segments, say this one, and these output line segments are interacting to form the triangles as we have shown here. But sometimes due to the locked set operations, we can see that this is not possible. Suppose if you see that the numerator has the 1 plus cos x plus denominator has the sin x plus 1, then straightening is necessary. Otherwise you cannot get the output line segments to interact such that the ratio effort is found. The ratio effort is a different thing than the Caliperness effort. We will focus on the Caliperness of effort now, because the grammar is non-commutative in the constructive geometry, and to depict this Caliperness effort we are coming back to the straightening part only. So in the engineering purpose, while writing the programs, the syntaxes are taken the non-commutative, and even in the share market data, the first data of the calibration calculations, we take one reference trend as the first term and we will hold it tightly, and then we will take the range up to which we will do the analysis, and this range has a geometric effort. This range is, say, taken like this, and now we have a range on which we are doing to the track forward and track backward, and then within that range we are finding the total geometric effort of the straightening. And the straightening effort is very important, because the total straightening to the line segment and total journey of this straightening is actually depicting the nature of the effort the total market has done to make the alignments of the final condition from the initial condition. The initial condition is hold tight, then we will sequentially straighten the whole trend sequentially from the last in first out way. The last segment is straightened first with the next one. This is like the multi-caliper where the multiple fulcrum points are there, and at every fulcrum points we will straighten it. We will never use the stretched straightening. We will never use this kind of stretched straightening, because the stretched straightening will change the edge lengths, and every edge length has a real effort that happened due to this trend setting. So real effort, we cannot remove the real effort, so we will not stretch these. We will simply try to get the sequential rotation of the last line segment trend to align it with the next last line segment, and then at every fulcrum points we will do these efforts clockwise, anti-clockwise, and we will measure the total efforts. Say, first, to calculate these efforts we will automatically measure the angles. Okay, so we will measure the angles first, and then we will decide the anti-clockwise rotation is going to give us a less effort, or clockwise rotation is going to give us a less effort. The least energy principle works everywhere. That is the Castigliano's theorem in the structural engineering, where not only human are lazy, but the whole nature is lazy. Nature tries to fit itself to such a position where it has to do the least effort. That is the Castigliano's theorem, and the least work principle is also applicable in the laws of nature. And if you go through the quantum mechanics also, there also you will find that least energy principle is a very important subject, and Lagrangian mechanics, Hamiltonian mechanics, and also in the Newtonian mechanics. After that, the whole analysis is done in that way, and even in the wave optics, also in the heat transfers, everywhere we have seen the least energy principle works best. And while trying to calculate the trend setting and trend calculations, the market will try to follow the least work principle. And in Sanjoy Nath'S Geometrifying Trigonometry, the straightening method before doing any division is necessary, where we have to find the least energy principle to decide which syntax is the best syntax to write the trigonometry expression or any algebraic expression. Suppose 1 plus cos x plus sin x can have a straightening effect. Cos x plus sin x plus 1 can have another straightening effect, and these effects have the efforts. And to get these efforts, whichever will give us the minimum work done necessary, that is the best way to write the syntax. Here, now after finding these angles as the theta 1, theta 2, suppose this one is the uh, theta last, theta n, the next one is the theta n minus 1. Say here, if we have to calculate the rotation necessary here, that is the theta n minus 1, and in this way we will calculate the efforts necessary to straighten. In this way we will calculate the necessary efforts to straighten in the whole multi-caliper objects. These are the multi-caliper objects where we first measure the in this way we first get the angles necessary to rotate, and then we will decide the anti-clock rotation fits best or clock rotation fits best, and whichever is the minimum we will follow that direction. In that way we decide the caliperness. Here the straightening is done, then this straightening is done, the sequential straightening is done. After these last two are straightened, then we will do the next straightening, and in this way ultimately we will go to the final straightening here, and the total rotation effort necessary is calculated here. For several cases we will see that this lifting and shifting are also necessary. Sometimes we will get the branches, multi branches occur in the triangulation. Sometimes we will see there are the multi branches occur, and these multi branches straightening are not so easy. To get those straightening effect we need to break the fulcrums. Sometimes we need to do the lifting and shifting. Suppose sometimes we need to do the lifting and shifting like this, and this also carry some effort. So the lifting and shifting effort is also measured with the breaking of the fulcrum effort plus the total distance lifting and shifting necessary. The sliding is done when sometimes we see that we have to slide the branch along any edge, and that is the sliding effort, and the total length we have to cover, that we have to take care. And in this way for several branching conditions we have to design the whole enumerative geometry with the purpose that we have to straighten the whole thing with the minimum effort, and that minimum effort is the caliperness. Here we have defined the total caliperness is the total effort necessary to do the planning, that is which point to cut, which point to rotate first, and from the syntax analysis we have to calculate this caliperness value, and after getting this caliperness value we can find the total minimum effort a market need to do to achieve a trend, or the total minimum effort the engineering system has to achieve geometrically to get a straightening effect such that we can do the division. And until we can do the division we cannot get the common triangle at which the two bunch of line segments interact due to the ratio. Whenever we see any ratio, obviously we have to understand that any ratio means some numerator is a line segment and the denominator is another line segment, and this numerator line segment is the output line segment of some bunch of line segment. The denominator is also the output line segment for the some other bunch of line segments. Both of these bunch of line segments are originated from the common single line segment L, and ultimately if no straightening is necessary, if everything are at par, suppose after doing the division if we see after doing construction of the bunch of line segments, if we see that the output line segment and the output line segment of the numerator and the output line segment of the denominator are automatically coming end to end and collinear, then those are naturally addable. If we see they are not end to end but overlapping, exactly overlapping, then and only then we can say the division is generating 1. That means we cannot say a division where numerator divided by denominator is 1 until and unless the output line segment of the bunch of line segments of numerator and the output line segment from the bunch of line segments in the denominator both exactly overlaps on one another. We cannot say the division is generating the numerical value 1. If we consider it as a numerical value of 1, then the whole system looks chaos, because our ordinary statistics don't answer these questions, our ordinary arithmetic don't answer these questions. Only Sanjoy Nath'S geometrifying trigonometry go deeper inside the total effort necessary to make the geometry aligned properly, to calculate the real trends, to calculate the real nature of the market movements. We have to understand the nature of efforts necessary to calibrate the ratios. Whenever we are calculating the ratios, we should get caution in our mind that numerical sameness is not going to tell us the real story. Real story is hidden inside the effort of straightening of the trend lines in the numerator and the efforts of straightening necessary to get the straight line segment in the denominator. Until the straightening is done, the division process will never give us the clarity about the trends. So whenever you will see the trend lines are there, get cautious that numerical statistics is never going to give you the answer until we are attacking the problems with the deep geometric nature of the movements.